In this video, we are going to look at service-oriented architecture, or SOA, a style that emerged from the pain of large tangled enterprise systems and laid the groundwork for the distributed architectures we use today. By the end, you will understand what SOA is, how it works structurally, and when it makes sense to reach for it. Imagine a large company where the billing system, the customer portal, and the inventory tool were all built by different teams at different times. Over years, they end up directly calling each other through brittle, custom connections. When one system changes, 5 others break. And if 2 apps need the same business rule, each team just copies it, so the rule drifts out of sync. That is the pain SOA was designed to solve. Here is a concrete way to think about it. Before shared electrical grids, every factory ran its own generator. Expensive, inconsistent, and hard to maintain. The grid standardized the interface, and everyone benefited from the same reliable supply. SOA applies that same idea to software. Instead of every application re-implementing common business logic, you expose that logic once as a service with a well-defined plug, a contract that anyone can connect to. Here is what SOA looks like structurally. At the bottom you have coarse-grained services. Each one owns a meaningful chunk of business capability, like customer management or billing. At the top are the consuming applications. The critical piece in the middle is the enterprise service bus, or ESB. The ESB is a central infrastructure component that handles routing messages to the right service, translating between different data formats, and enforcing the shared contracts that all services agree to speak. Let us trace a real request. Say the CRM application needs to fetch a customer's order history. It sends a standard format message to the ESB. It does not know or care where the order service lives. The ESB checks that the message conforms to the agreed contract, then routes and possibly transforms it before delivering it to the order service. The service runs its logic and returns a response, which the ESB sends back to the CRM. The key consequence here is decoupling. The consumer and the service never speak directly, so either side can change independently as long as the contract holds. SOA shines in large enterprises where dozens of heterogeneous systems need to share logic and data through a governed, standardized layer, but it carries real costs. The ESB, by centralizing so much responsibility, routing, translation, orchestration, can itself become a bottleneck and a single point of failure. The heavyweight contracts and XML-based standards that SOA typically uses can also slow down teams that need to move quickly. For smaller products or startups, that overhead is rarely worth it. If you do adopt SOA, a few principles will save you serious pain. Start by defining your service contracts clearly. They are the promise each service makes to its consumers, and everything depends on their stability. Resist the temptation to put business logic inside the ESB. That turns it into a hidden application that nobody fully understands. Use the ESB strictly for routing and translation. And if your organization has small, autonomous teams rather than large cross-system integration needs, microservices, SOA's finer-grained successor, will likely serve you better. To wrap up, SOA solved a real and serious problem, the tangled, brittle integrations that plagued large enterprise systems, by introducing the idea of reusable services with explicit contracts and a shared bus to mediate communication. It works well at enterprise scale, but brings real operational weight. Understanding SOA matters not just historically, but because its core idea, expose capabilities as independent, callable services, is still central to how we design distributed systems today.